Yeah. Can you see the screen, PPT?
Yes, sir.
Fine. Yeah. So far, in module one, we started off with basics of stress strain, then stress strain diagram, then what is bending stress, what is torsional shear stress, and what are the equations that are used for calculation of combined stresses due to combined loading. Then we learnt about principal stresses. Then combined loading, that's what we learnt in module 1, which had introduction and design for static strength. Next, in module 2, we learnt about impact strength and derived the expression for impact strength given by sigma I is equal to sigma of 1 plus root 1 plus 2h by delta, and delta was static deflection, and sigma was the static stress, sigma I is impact stress, right? And we solved few problems based on that. Then we learned about design for fatigue loading. So in that, when components are subjected to combined variable stresses and also variable stresses, we derived a Soderberg relation. And based on Soderberg's relation, we solved many problems where components are subjected to variable stresses. So in the beginning, we did the component subjected to only variable bending stresses. Then we learned about components subjected to variable axial stresses. Then components subjected to variable shear stresses. Then in later stages, we learned about combined variable stresses, right? When the component is subjected to variable bending and also variable torsion, variable bending as well as variable axial stresses. This is all what we did in module 1 and module 2. From now on, if you look at here in module 3, we have design of shafts, design of keys and couplings. Then we have design of permanent joints such as riveted joints and welded joints. Then design of temporary joints, threaded fasteners and power screws is what we have got. So if you look at module 1 and 2, it is basically the extension of whatever that we have learned in our mechanics of materials. They are all complete basics. So from module 3 onwards, it's all about design of components. Is that okay? Are you there with me? Are you there?
Yes, sir.
Yeah. So now from today onwards, we'll start with module 4, which is design of permanent joints, and in that we have riveted joints and welded joints to study. So we start with welded joints. Do you all possess the data handbook that I had given supplied to you about riveted and welded joints? Do you possess
Yes, sir.
it? Yeah?
Yes, sir.
Excellent. So that's what we are going to start with module 4, wherein we take up welded joints in the beginning. Let's look at the definition of welded joints. Basically, we know welding is a process of joining two similar or dissimilar metals by heating to a suitable temperature, that is to the melting temperature of a given material, with or without the application of pressure, right? This is what we learned, the basic definition of welding. And in welding, we have two types of welded joints, basic forms, right? There are other types of welded joints also, but basically we have two types of joints. One is lap joint, another is butt joint. So what is butt joint? When you butt two pieces of metal side by side and then do the welding, then do the welding like this, then it is called butt joint. That is, the two metal pieces are butt against each other, and in between the junction of them we are going to do welding. So such type of welding is called butt joint. And lap joint, wherein we will have overlapping of two metals, something like this. Can you see? So when you have two metals overlapping with each other and then we carry out the welding to join those two pieces of metal, then it is called lap joint. That is, overlapping with each other is lap joint, butting against each other is called butt joint, right? So in butt joint, they butt against metal pieces to be welded or butt against each other, whereas in lap joint, the metal pieces that are to be welded will be overlapping with each other, right? So that is called lap joint and butt joint. Then other types of welded joints we have seen here, butt joint. This is lap joint. This is where we carry out the welding, maybe single or double, something like this. Then we have corner joint, T-joint, and edge joint. These are all the various types of welded joints. Now, coming back to, we are interested in lap joint and butt joint only, okay, for our classroom design. So we are interested in lap and butt joint. In lap joint, we have transverse fillet weld and parallel fillet weld. There are two types of welded joints. One is transverse. What do you mean by transverse? What do you mean by transverse?
Perpendicular to the axis.
Yeah, perpendicular to the axis of loading is called transverse, right? So we have transverse fillet weld and we have parallel fillet weld, which is parallel to the axis of loading. This is what is seen here. This is parallel fillet weld, right? So this is how the parallel fillet weld, where if you see the darkened portion over here, that represents welding, right? So this welded joint is parallel to the axis of loading. So therefore, it is called parallel fillet weld. Okay. That is, welds parallel to the axis of loading are called parallel fillet welds. Then what are transverse fillet welds? Welds which are perpendicular to the axis of loading are called transverse fillet welds. How does it look like? It looks something like this. If you look at this, right, this welding is perpendicular to the axis of loading. And one more observation between this figure and this figure. What is the difference between these two? About this and about this I am talking about. Talk about that. Yeah? What is the difference?
Fillet has been given on the bottom side. The welding has been done on the bottom side.
I could not still get the clarity. I'll tell you. This is transverse weld. You agree? Because it is perpendicular to the axis of loading. And if you do only welding at one location, then it is called single transverse weld. When you do welding at two locations like this, it is called double transverse weld. Okay? Got it now? Got it? So, welds which are perpendicular to the axis of loading are called transverse fillet welds. Alright. So, when you have welding at only one location, then we call it as single transverse fillet weld. When we have welding at two joints or two locations, we call it as double transverse fillet weld. Is that okay? And this is what? This is parallel fillet weld. Got the difference in the same figure now? This is parallel fillet weld. This is single transverse fillet weld. This is double transverse fillet weld. When I combine this two, that is, I add one more weld over here, something like this, then it is going to be called combined fillet welding. It will contain both parallel fillet weld as well as transverse fillet weld. Then it is called combined joint. Are you with me? Are you with me? Yeah?
Yes, sir.
Yes, sir.
Yeah. So we have two types of welded joints. One is lap joint and butt joint, basic classification. Then in lap joint, we have single transverse and double transverse fillet welds. Then we have parallel fillet welds. Please keep in mind, parallel fillet weld is one wherein we have weld which are parallel to the axis of loading, whereas in transverse fillet weld, we have the weld which is perpendicular to the axis of loading. Okay? And one more important aspect is when you have parallel fillet weld like this, the welded joint is subjected to shear stress. Okay? Welded joint is subjected to shear stress, whereas the transverse loading case, the welded joints are subjected to normal stresses. Is that okay? Is that okay? Normal stresses. So transverse fillet welds are subjected to sigma normal, and the parallel fillet welds are subjected to shear stress tau. Okay? Fine. What you do, you please make a note of these joints into your notebook for time being. Just make a note of this because once I start presenting, this may go off your mind. Please make a note of these three sketches into your notebook. Please make a note of these things in your sketchbook. Meantime, I'll take attendance.
Sir, only this slide.
Yeah, only this slide these three sketches you please take down and note down whether it's single transverse, double transverse, parallel fillet. Okay. Yeah, answer your roll call. 1,
Answer.
2, 3, 4, 5, 6, 7, 8,
Present, sir.
9, 10,
Present, sir.
11, 12,
Present, sir.
13, Charishma, Chandan Swarup, sorry.
Present.
Yeah, 14.
Present, sir.
Yeah, 15,
Present, sir.
16, 17,
Present, sir.
18, 19, 20, 21, 22,
Present, sir.
23,
Yes, sir.
24,
Present, sir.
25, 26, 27, 30, 31, 32, 33, 34,
Yes, sir.
35, 36, 38, 39, 40,
Yes, sir.
41, 42,
Yes, sir.
43, 44,
Present, sir.
46, 47,
Yes, sir.
48, 49, 49, 50,
Yes, sir.
52, 53, 54, 55, 56,
Present, sir.
57, 58, 59, 60,
Yes, sir.
61, 62, 63,
Present, sir.
64, 65, 66,
Present, sir.
67, 400,
Yes, sir.
Mahesh Madiwal, Nishant, Ramesh, Shashank,
Yes, sir.
Akshat, Sautrik,
Present, sir.
Mahima Raj,
Present, sir.
Srivatsan,
Present, sir.
Suman Xavier, Madan Kumar, Manu, Shadab, Ganesh, Vijay Kumar,
Yes, sir.
Rishi S.
Sir, Vijay Kumar, sir.
Oh, okay, I've taken Vijay Kumar. Zahir Hussain. Hope you have noted down the.
48 present, sir.
Yeah?
48, sir, present.
What's your name?
Sanjayan, sir.
Sanjayan.
Sir, 43 present, sir.
Hey, what you people will be doing is say.
Sir, I was writing, sir.
Huh?
I was note downing, sir.
Oh, good. Finished, huh? It is not called Rakshit. Are you there?
Yes, sir.
It is not note downing. It is noting down.
Note.
Okay.
Okay, sir.
Okay. All right. So finished with this?
Yes, sir.
Yeah. Now we'll move on to the cross section of the weld, how the cross section of the weld will be. So you can see the sketch over here. This distance is called the throat, okay, throat of the weld, right? And this is the weld size. So throat will be equal to 0.707, that is cos 45 times size of the weld. So therefore, I have written here throat is equal to cos 45 into weld size, okay? That is equal to 0.707 W. W stands for size of the weld. Please note down this. T is equal to W into cos 45, that is equal to 0.707 W. Please note down this. The cross section of the weld is to be taken as a right angle triangle. So from right angle triangle, we get the throat to be equal to cos 45 times the weld size. That is 0.707 W. It's a very easy topic, so try to learn clearly. Finished, yeah? Yeah. Now, come to parallel fillet welds are subjected to what? As I said in the beginning, they are subjected to shear stress, okay? Parallel fillet welds, which is given over here, okay? Parallel fillet welds are subjected to shear stress, so tau is equal to P by A, okay? Tau is equal to P by area of cross section of the weld. That is nothing but throat into length of parallel fillet weld. That is length of this parallel fillet weld into throat size, where LP is equal to length of parallel fillet weld. So therefore, tau is equal to shear load divided by 0.707 into W into length of parallel fillet weld. Why it is 0.707 W is because of the throat, okay? Throat of the weld is given by 0.707, that is cos 45 times W. So therefore, throat is replaced by 0.707 W into a length of parallel fillet weld. Length of parallel fillet weld is length of this plus length of this weld. Put together is total length of the weld. So from this again, from this equation, I can extract P shear, because shear load is given by 0.707 W into length of parallel fillet weld into shear stress. Just cross multiply this denominator to the left hand side. Okay, we get P shear. Is that okay? Please note down this equation. Please note down these equations.
Sir, can you shift the PPT one, sir?
Pardon me?
The previous slide, 1 second.
Yeah.
Okay, sir.
Yeah. Please note down, parallel fillet welds are subjected to shear stress. So therefore, tau is equal to P by A, load by area of cross section. That area of cross section is given by length of weld into the throat distance.
Excuse me, sir.
Yeah? Yeah.
Excuse me, sir. If you
Yeah.
don't mind, can you go back to the first slide?
This
The
one?
slide before this.
Before this? Now is it okay?
Yes, sir. Yes, sir. Yeah.
Done?
1 second. Yes, sir. Okay. Thank you. Yeah, sir.
Please note down this equation, and transverse fillet welds are subjected to normal stress. Again, note down these equations. Stress is equal to load by area of cross section. Length of normal fillet weld is Ln. Okay, that is the total length of normal fillet weld. This is not there in this. Okay, so length of normal fillet weld into throat. So throat is 0.707 W. So note down these two equations. Please note down the contents of the slide. Finished, huh? Finished, noted down, noting down.
So 1 minute.
Yeah.
Yes, sir.
Yeah. Now, as I said, when you combine parallel fillet weld and transverse fillet weld, what you are going to get is what is called compound fillet weld. Okay. So this will give you parallel fillet weld LP. This is transverse fillet weld length LT. Okay. So LN. Okay. I'll put it as LN because we have taken LN. So when you have combined parallel and transverse fillet welds, then such welds are called compound fillet welds, right? So in such case, the total load by the compound fillet weld is the sum of load because of normal fillet weld and load because of shear. Okay, shear, load because of parallel fillet weld. Okay, load because of transverse weld, load because of parallel fillet weld. So put together, the total load is equal to P normal plus P shear. What is P normal? We have taken here. P normal is 0.707 W into length of normal fillet weld into sigma, whereas P shear is 0.707 into W into length of parallel fillet weld into shear stress. All right. So same thing I have written over here. So the total load shared by the compound fillet weld is equal to load shared by normal fillet weld plus load shared by parallel fillet weld. Is that okay? So therefore P is equal to, note down this equation. Note down compound fillet weld, note down the sketch quicker, and note down up to this equation. If we are finished, we'll go further. Did you finish?
Yes, sir.
Done?
Yes, sir.
Yeah. Now I have put note over there, that is to take care of ineffective or incomplete fusion. Okay. 5
Yes,
mm
sir.
is added at each free end, right? So whenever to compensate for incomplete welding or ineffective welding, 5 mm is added extra at each end of the weld. That means when you look at the sketch, you have one free end over here, you have another free end over there, right? So to take care of ineffective or incomplete fusion, a additional length of 5 mm is added to total weld length. Okay, so that is what I have taken over here. Total length of the weld will be effective length, whatever that you are going to find out from LN and LP over here, plus 5 times number of free ends. I stands for total number of free ends. So in the compound weld here, we have 2 free ends. Can you see that? In compound fillet weld, we'll have 2 free ends. So therefore, for a compound fillet weld, I will be taken as 2. Okay, whereas when you go back to parallel fillet weld over here, you will have 1 free end, another free end, third and fourth. So you will have I to be equal to how many? I to be equal to 4. Correct? Correct? Okay, so that is number of free ends will be 4. So the effective length will be summed up with 5 times 4 ends over here. That is effective length plus 5 fours are 20 mm will be added to the total length of the weld. Similarly, how many free ends are there here in single transverse weld? How many free ends are there?
2.
2, yeah. And in double transverse?
2. 2 only, sir.
No, this is 2. What about these 2? Okay,
Oh,
so
yeah.
you'll have
Yeah.
4 free ends, right? So we'll have 4 free ends in double transverse weld. Okay, and that's how we need to take the value of I. Please take down this. Please take down to take care of ineffective length or incomplete fusion. The effective length will have, that is 5 mm is added at each free end for the effective length so that we get bigger or total length of the weld. Please note down this. This is very, very important. Please note down that much. Total length of the weld is equal to effective length plus 5 into I. Where I is total number of free ends.
Done, sir.
Yeah. Okay. I think before we go to the problem, what I would like to is you people to go through whatever that is done and get yourself familiarized with these equations. Please go through, take 2 minutes, go through whatever that is done so far. Okay. Please go through, or once again you write down the equations, try to understand what each of them are. I'll give you 2 minutes. Please go through whatever that is done so far.
So can you put that slide with throat?
Yeah.
So what is LS in this?
No, don't worry about it. It's actually called leg size, but we take it as weld size, W. Okay?
Okay.
Yeah. Because if it is a regular class, no, I would have written the cross section and indicated it as W. Since I have downloaded it from internet, so I cannot change that LS and all. So maybe I can strike off and write W here, probably.
So the diagonal line is the throat, sir, throat length.
Yeah, this is throat length. That is the distance here. Okay, or what I would say, this distance. This distance is throat.
1 minute, I will take down that.
That's what he has indicated here, no? Throat.
Excuse me, sir.
Yeah.
Sir, is it considered that the whole weld is uniform? Like it's
Yeah,
uniform?
definitely. Yeah. Definitely, it will all be taken as uniform weld. Okay. See, nowadays you have got electron beam welding machines, stereo. I mean, what is that other one? Friction stir welding. Okay. You have highly automated welding machines available, and robotic welding. Normally, they go for robotic welding in automobiles. Okay, where it is expected to have 100% accurate welding. Okay.
Yes.
So, yeah. So it is taken to be uniform welding. If human intervention is there, then as I said, there can be non-uniformity. And if you would have done welding, have you done in your workshop welding?
Yes, very not at all uniform, sir.
Yeah. That is there. So that's why normally welded joints in automobile sectors, they use robotic welding. And one more important thing is if you go to telescopes, no, radio telescopes and bigger telescopes, there also they use welded joints. And I missed out my Indian Institute of Astrophysics job because I did not had good grip over welded joint fixture designing. Okay, of course, long back. So these things. So though these topics small looks not so good, but they suddenly become more of importance.
Got it, sir.
Yeah. Yeah. Now we'll take up a problem.
Excuse me, sir.
Yeah.
I have a doubt. Like in the transverse thing, in the transverse fillet one,
Okay.
the formula that you gave was only for one-sided, for single transverse or double transverse also?
See, normally we find out length of the fillet weld. Okay. We'll find the length of total weld. Okay. And so it will be given whether it's single transverse or double transverse. It will be for single transverse we find out, and then if the length will be multiplied, length of weld will be multiplied by 2. That's it. Okay.
Yes, sir.
Yeah. Please note down this problem. A structural steel plate 100 mm wide and 10 mm thick is to be welded to a steel plate by parallel fillet weld and has to carry a load of 20 kilonewton. Determine the length of each weld for static and dynamic loading so that the maximum shear stress is not to exceed 60 megapascal. Please note down this problem. So if you note it down, so we have a steel plate which is 100 mm wide, okay? That's the value of B over here, and 10 mm thick, right? Why 10 mm thick is taken as W or H here? Because when you look at the welded joints, right? So this is, okay, this will be equal to thickness of the metal piece, that is equal to, so therefore we equate that to weld size W. Are you with me? Are you with me? Yeah?
Yes, sir.
Okay.
Yes, sir.
Yeah. So come back to the problem over here. So therefore 10 mm thick plate, okay, steel plate of 10 mm thick, right? So therefore we have taken W to be equal to 10 mm is welded to a steel plate by parallel fillet weld. So therefore, since it is parallel fillet weld, it is subjected to shear stress. And first determine the length of each weld for static and dynamic loading, so that the maximum shear stress is not to exceed 60 megapascal. All right. So what we need to find out is determine the length of each weld. So here we are given with static and dynamic loading. So for dynamic loading, for time being, hold on. So let's look at for only static loading. So for static loading, when you look at shear stress is given by P by 0.707 W into length of parallel fillet weld. This we have understood earlier. So go there, you will get length of parallel fillet weld, and therefore total length will be equal to length of parallel fillet weld into plus 5 times number of free ends. So for a parallel fillet weld, we have 4 free ends. So that will give you the total length of the weld. Is that okay? Is that okay? Please note down for up to static loading. Then we'll go to dynamic loading, because there is a small thing that need to be taken from the data handbook. Please note down the solution.
Sir, I didn't understand how you took W is equal to H something.
Yeah, I'll come back. Yeah, can you see the sketch now?
Yes, sir.
Yeah, so this weld size W is equal to thickness of the plate over here, correct?
Yes.
This distance, right? So therefore, when he gives thickness of plate, we can take it as equal to weld size. Is that okay?
Okay, sir, got it.
Yeah. Okay, students, we'll meet next class. Okay, because we have to go for COVID test now in the college, right? So we'll see you next week. Okay.
Yes, sir.
Thank you, sir.
All right.
Thank you, sir.
Thank you, sir.
Sir,
Yeah.
so we won't have the next class.
Pardon me.
We won't have the next class, sir.